With these problems, you're basically asked to simplify. Okay, and if you're confused by that funny looking b, that's beta. You could write it as sine x as you do the problem, if that helps. And actually I'm going to do that because I'm probably going to make a messy beta. So what you should do is use the fact that tangent and cotangent can be written in terms of sine and cosine. Like tangent beta, that's the same thing as sine over cosine. And then secant, write that in terms of cosine. Secant is 1 over cosine. And then cotangent, that's cosine over sine because it's just the reciprocal of tangent. So if you haven't seen that before, that tangent is sine over cosine, that's important for these types of problems. And then secant, that's the reciprocal of cosine. So now that we have that, look, there's a bunch of cross-canceling that can happen. These cross-cancel, these cross-cancel. We're left with a sine of x in the numerator and a cosine of x in the denominator. But we said at the beginning, that's just tangent. So our whole thing simplifies to be tangent. Same type of thing here. Let's put everything in terms of sine and cosine. I'm going to write sine x because my thetas look really ugly. And I'll just remember x is theta. Tangent is sine over cosine. And then cosecant is 1 over sine because it's the reciprocal of sine. So this cross cancels. So I get sine x over 1 times 1 over cosine. So if you multiply straight across the top, you get sine x over cosine x, which is the definition of tangent x. Well, not the definition, but that is tangent of x. It's equivalent. Okay?